Welcome, everyone. My name is Tim Stewart with Visual Decisions. I'm here with a couple gentlemen from Sandalwood, and we are going to be talking about edge computing with Ignition Edge today. Bob, Frank, welcome back to the show, and thank you for rejoining me.
It's always a pleasure, Tim.
Yep. So let's go ahead and get started. If we look at edge computing and the reason that we're going to talk about that today, there's a very big problem out there in terms of manufacturing downtime. And let's talk about how edge computing can help us with that.
Sure, I'll kick it off, right? And I think this slide sort of highlights it, right? There's several studies from Deloitte, Industry Week, published over in the Wall Street Journal, right? Downtime is costing U.S. manufacturers around $50 billion a year. So when we're talking about this is, unplanned downtime. I know for a fact if a engine line goes down, that's servicing an assembly plant. We're talking $3,000-$4,000 every like 30 seconds.
Yeah.
There's all the cost that goes into that. Not just lost productivity, but your timelines get out of hand, your quality goes down. And the issue with that is the root cause often goes undetected, right? Until it's too late, because you're sort of scrambling to band-aid the issue. What's the problem? Just fix it and let's move. Let's fix it and let's move. And the underlying issue is never addressed.
You and I have been in this industry for a long time. Bob, you've been in this industry for a long time. And, we started off doing things in a very manual way, collecting that information from the shop floor using tick marks on, pieces of paper and so forth. And if we think about what the capabilities are today, we've come an awfully long way. So I don't know if you want to go through some of the details here, Frank, but, why don't you walk us through some of what we can do with edge computing?
Sure. And when we're talking edge, and Bob, you can jump in at any time, right? It's pushing that issue resolution, that identification, that enunciation as close to the point of where the issue is generated, right? Traditional SCADA systems, they collect the data, but depending on where that central hub is, it might be too late to address them, right?
Mm-hmm.
Predictive insights, like it says on the screen, right? They should happen where it originates, right at the edge. So over the last, especially 10 years, the bottleneck used to be, the network's big enough, it can contain the information, send it all up. Now we're starting to increase the amount of information we want to go through and collect, and that pathway is starting to get bogged down. Conversely, the computing power and the cost of it has dramatically reduced. So edge computing empowers operations with real-time analytics and alerts, right again at where where the issues reside.
I want to jump on that, Frank, because some of the newer edge devices are actually now have included in them a GPU processor, so they can handle the load of the neural network or machine learning algorithm to be able, and even in some cases AI, to be able to do that analysis right there at the line for data that's coming into it, and provide the feedback to the operator directly from that edge device, as opposed to having to go through a cloud platform to be able to get that insight and feed it back.
For sure. And you're no longer dependent on, all this data is flowing in, waiting on that central hub, whether it's an on-prem server, a corporately hosted server somewhere, thousands of miles away, or in the cloud, right? It takes time to get the data, ingest the data, transform the data, and then actually do some of the detection, right? So doing that analytical detection right at the edge It's just results in a faster response from the system alerting, and that means it's a faster response to mitigate the issue.
And I think there's another side of it as well. It's not just the speed with which you can collect the data and process it, it's how quickly you can utilize it once you have done that as well. And so whether you're passing that information to a human along the line and prompting some action, you can do it so much faster if you're processing those things locally. But it's also, once you start getting into prescriptive capabilities with your systems, having those capabilities on the edge and that lower latency connection back to the machine to tie into the controls and so forth is very important.
For sure, it is. As Bob mentioned, right? The computing power of those edge devices has increased exponentially to the point where, again, as he mentioned, you can now load AI. They can run sophisticated algorithms to enable actions.
And so as we go through this, let's define our terms a little bit. It's kind of intuitively obvious what edge computing is, but let's give a little bit more definition around that.
Sure. So when we look at edge, I've said it multiple times already, right? It's processing that data close to the source or next to the machines, right? It's a way of gathering information that, again, deals with it close to the source and actually enables only the most important of that information, subset of information, get pushed up. It reduces dependency on cloud or centralized servers for decision makings. And importantly, when you're at these remote sites, think like oil and gas, it can work independently of that central server. So if you have bandwidth issues, you can't, like, it's not hard piped in, you might be using cellular, you want to make those decisions at the time that the issues occur and maybe do a burst messaging over to your central server. I don't know if you got anything more to add to that, Bob, or?
No, you're right on there.
All right.
That's
Let's
fine.
see. So, for me, it becomes important because not only for the reasons that we talked about earlier in terms of the latency and so forth, but it's also a source of risk mitigation, right? You can still continue running when you don't have access to that central server. So if the internet goes down or whatever it might be, you can still run locally, collect all the information you need, still have those controls in place and so forth. So not only is it providing value normally, but it also helps reduce that risk. In terms of the architecture, how does the architecture differ for traditional implementations versus an edge?
I could take this one. From a traditional model standpoint, we've usually been dealing with centralized systems that were linking these devices at the line or the workstation up to, and they've, it's usually a point-to-point type connection that has to be defined for each device. And so with that comes typically a high latency between the devices and the centralized systems, and then back to, say, an HMI to an operator. And in some cases, if you're going to the cloud, that latency could be even higher. Whereas with an edge model, you're dealing with more of a distributed architecture, where the sensors or other devices are communicating to that edge gateway. And that edge gateway is doing the initial processing, which includes data collection, but can also do other things like handling the alerting and doing other higher end activities like doing data analysis to gain insight from that data and feed it back then to the operator. And oftentimes these edge gateways then will continue to push data to the central systems, but you're not. It's more of a publish.
If I could just add to that, right? You know, we talked about the bandwidth too. So when you're doing all that processing at the edge, you don't necessarily have to send all the process data up to that centralized server. So you can go through and summarize the data, transform the data, and a smaller subset of that data can be sent up for more insightful analytics. You still have, again, depending on the platform, and we'll talk about Ignition, Edge, you still have that data that's being collected, but it's not all being shunted over in real time. And so it's just the important data that gets sent over that can start, you know, if we're talking a SCADA, that information can interact with with your ERP or your MES system, and you're leaving those you're allowing your bandwidth to be open, right, for other items and issues.
And to me, the graphic that we have here shows kind of a simplification between the traditional model and the edge model. But I think that even undersells the difference, because that's just kind of the one-way transmission. If you also look at the insights and those coming back to the user and so forth, those are things that are going to, also be simplified as you go through that local connection. If we look at the key benefits of this on the next slide, what we've kind of talked about most of these already. So, if we look at the benefits, it's reducing latency, and for that entire closed loop, both coming from the machine as well as going back to any controls and so forth. And that can be critical for high-speed machinery, safety systems, and so forth. If we look at improved reliability, again, it's reducing that risk. So if your cloud or your internet goes down, you can still be running. Some of the bandwidth optimization, being able to summarize some of the information because you're handling some of that processing locally, so you can send up only what you choose instead of having to send everything back up to the cloud. And then enhanced security, because you can do a lot of the most important things locally instead of sending all of the critical information elsewhere again. And so those are some of the key benefits. Frank, can you share your thoughts on those?
Yeah, and I'll go to that enhanced security, right? Because now, to your point, especially today, you want to reduce that attack vector, that surface. So if you're doing everything on your OT network or operational technology, so we're talking the sensors, the PLCs, and whatnot, you don't have to harden all those points. You should harden all of them, to be clear. But when talking exposure to your bigger systems, especially your IT systems, you can go ahead and concentrate a lot of your work right at that ingestion point from the OT to the IT. And the reliability is the other thing I'm just going to touch on because it happens. You can run for years and never have an issue with your platform or your cloud, but it's that one time that it goes down. You still got to be able to operate the systems and the edge devices that you have should be able to compensate, hold on to the data, still work without that without needing to hit the cloud or that central gateway.
Yep. Bob, do you have anything to add on this one?
Yeah, the other thing you definitely can do at the edge is do, instead of collecting just raw data and sending it on, you can use the edge device to do the normalization of that data, right? And the standardization of the payload that gets sent onward to other systems, like an MQTT broker, for example.
Right.
Instead of sending the raw data that's unprocessed and having to do it at a higher level in the architecture.
Yeah, so that's a great point. Not only can you make all of these differences, but you can also enrich and contextualize that information right at the edge before you send that to the other systems. I think next we have why edge computing is so important now. I mean, some of these capabilities, obviously with the hardware and software that we have today, there's more capabilities at the edge. But why does it matter so much more now than it did in the past?
Well, for one thing,
So
the number of devices are going to be exploding here, right? Over the next few years. We're already looking at 75 billion connected devices by 2025, which is today. So, and it's only going to grow exponentially from here. So, being able to segment that into more easier pieces, right at the edge, and we talked about the contextualization of the data before we send it. Being able to do that in smaller pieces helps you keep helps you distribute the load across the network.
Frank?
yeah, just the sheer amount of data, as he said, as we're getting 75 billion connected devices, hopefully not all in your plant. With that, right, you got a glut of information, and there's a reason why you want to go through and collect it. So the modern manufacturing, you need that instant response. If we're sending all this data, I want to be able to use this data now, not have to wait, depending on your architecture, for something to get up to the cloud, have it processed, run through your rules, and then send down some sort of alert. So moving all that that computing over the edge really helps enables those real-time responses to issues. And just to go on that, the regulatory compliance, when you're talking about like pharmaceuticals and whatnot, is intense, and you can build all of that right in at the edge. I'm just going to say one more point too. If you go through and develop your edge strategy properly, the self-subscription of adding new IoT sensors or machines, that just enables a quicker uptake into your system. If you're using edge, if you're using computing at the edge, you don't have to worry about as much everything after the edge, because if you do it right, you contextualize the data, and then the rules that you built take over automatically. And again, you're only pushing the insights up to the cloud, and the platforms, if you pick the right one, can automatically be set up, or can be set up to automatically ingest those new messages with little overhead.
So
Configuration changes.
So speaking of the right one, we talked a little bit about a comparison between traditional architecture and edge architecture. Can we get a little bit more into detail on what that edge architecture actually looks like?
Yeah, sure. I mean, when you're working with the edge architecture, it basically breaks it down into the 3 layers, right? So you got your device layer, your OT devices, your sensors that are running, that you're running, and then you have this edge layer, which is components that are processing units that are sitting close to these areas, relatively networked, actually run as a Dockerized container on that same equipment to do that processing. And then all you're doing is you're setting, again, the insights to the 3rd layer, which you could call the cloud layer, your server layer. That's where you do some higher level analytics, your visualization, like your core visualization, to your engineering. is done. You can actually do at the edge layer localized UIs and interfaces to work on that subset of devices that you have connected there.
Okay. Bob, do you have anything to add?
No, I think Frank summarized this slide pretty well.
Okay. I guess next then, let's talk about why edge computing isn't everywhere. I mean, we're making it sound like kind of a panacea that everybody should just immediately go out and do. What are the things that are preventing people from actually doing this today?
Sure. I've highlighted like 5 of these, or we've highlighted 5 of these, right? So complexity. When you start going the edge, there's a lot of pluses, but you do have to be able to manage distributed systems at scale, and that might, especially initially, might be resource intensive. The integration. So you're talking about pushing it to the edge. These devices have to be able to talk multiple protocols, and especially with legacy systems, that can add issues. And the idea is you might have what looks like a spider web coming into these edge devices, but once you contextualize it, you go through the exercise of setting up maybe a UNS or a CDM protocol. That transformation happens at the edge, so everything coming off the edge is talking the same back to the system. So that there's some work that has to be done, a lot of work that has to be done on the, we'll call it the left side of it, where the machines are. But once that work is done, you can instantiate those rules at the edge, and then we're talking commonly to your SCADA system or your MES or your ERP. Ideally, you want all those major systems talking in the same language, which again can be facilitated by a CDM or what's known as a common data model.
Okay. Bob?
Well, and the other thing is scalability could be an issue. What works on one line doesn't necessarily work on another. And once again, you got to do a lot of that work up front to be able to say, okay, this is the type of data we want from our equipment, and standardize it. And there may be some devices that just that don't produce that data. So you'll either have to go in and modify those devices to be able to provide that information, or find another way to collect it.
Yeah, I was going to say, and this goes to the complexity of the system too. Maintenance, when you're moving to that edge environment, you got to keep them up, right? So you're building in methods in your architecture for monitoring, making sure that the devices are connected, the system is secure to the endpoints, right? You are offloading some of that security down to the edge. So all that is, it is not an unsurmountable barrier, but those are all things that you have to consider when moving to an architecture such as edge.
Okay. Just, from my own personal experience, I would throw cost on there as another traditional barrier to moving forward with this. Looking at the cost of some of these machines that were kind of edge capable in the past and industrial hardened, they have been pretty pricey. I mean, as with a lot of hardware, those prices have been coming down consistently, but at least in the past, I think that's been something that has prevented companies from doing this. And maybe they didn't have a clear definition of what that value proposition looked like to be able to justify those kinds of things. But the other side of that we can think about in terms of why that cost and value proposition hasn't been there is that some of the traditional solutions in this space haven't really been up to muster, so to speak. So let's talk a few minutes about some of those traditional solutions and where they've fallen short versus what we can do today.
Sure. This is a very simple chart, right? So when we're going through, we broke this up: development, integration, vendor lock-in, which is huge, right? And then the cost and scalability. Uh, so in the traditional system, right, the monolithic, it takes months, potentially months of custom coding to go in and do the work or start adding additional assets to your deployment. And what Edge can help you do is you can get, if properly planned out, right, to that drag and drop sort of configuration. A big one is, traditional solutions may be limited as far as their protocol support. What we need is going through at the, if you can't get to those open standards, at least a method for ingesting, some of those proprietary protocols and making an output of that system open through, an MQTT with a JSON payload, those sorts of things. I'll let Bob talk to the cost and the other ones, but vendor lock-in for hardware and software is huge. We know there are really good systems that are out there, but you better buy, PLC type ABC and make sure the sensors you buy are from, ABC supplier and this and that, and then the systems work great. But it's the second you start moving into, specialized controls or something that doesn't adhere to that vendor's sort of footprint, it becomes an issue. When you're going to the edge, again, you can take sort of that cacophony of signals and protocols, and they can be re-architected or reorchestrated into that one flexible call it communication center deployment options. So it doesn't matter what you have coming in, what's coming out is the same, or at least structured in a way that can be read by multiple systems, not just the one you have.
Yeah, from a cost and scalability standpoint, they kind of go together. From a scalability standpoint, traditional systems, you typically had to do configuration for each end device up to whatever the data collection point is within your platform, right? So every one of those devices had to be configured within the platform. And so that leads to high service costs because you got to have somebody like a systems integrator to go in and do that for you if you don't have the resources in-house. And so what we're really looking for is being able to scale more easily so that you're not having to, you have the self-discovery of those endpoints from the edge that can then publish to the corporate environment. And you can do that by utilizing templates within the platform that's running on the edge for various types of devices.
Okay. I don't know if it was audible while it was happening, but I actually had the ice cream man drive past my house. It's, I don't know, 140 degrees out or something like that. And I was desperately sitting here trying to think about how I could take the ice cream man and relate that into the edge discussion that we're having right now, because it feels like that should apply here somehow, but I just couldn't figure out how to make that metaphor work.
Number one ice cream, Tim. This is thanks for that.
You're welcome. So let's shift the conversation a little bit away from ice cream and help Frank get past that. One of the solutions that we all very much recommend here is Ignition Edge and the Ignition framework overall. Could you guys give us a quick run through on why it's such a game changer?
I'll give it a stab. I won't talk too much to this slide, but the way when I explain ignition edge to people, it is everything you love about ignition in a smaller package. That's basically, it's more lightweight. It's got the full functionality that you would, that you have over, in ignition. It seamlessly integrates with ignition gateway, but the beauty is you don't need to use ignition gateway in order to use edge. Um, that's the pitch. It's gateway, basically minus SQL, and a limited front end, or you can choose not to have it at all. So all you're doing with it is doing the processing. I don't know, Bob, if you want to add to it.
No, yeah, it's really a slimmed down version of the main product. And as Frank said, everything from you don't have the integration to components for connecting to databases and stuff like that. You still need to go through a normal ignition gateway to be able to do that. But you can connect all your ignition edge gateways to that gateway, so that communication and feeding other database systems is possible. And there is a really slimmed down version where you don't have anything from an HMI perspective, where it's just doing the data processing and data collection. And then there's the edge panel, which does allow you to be able to build some visualization from an operator standpoint.
Okay. Sounds like my wife would love this because she likes anything that's out there. If they come out with a mini version of it, she's always all over it. So sounds like she'd love the skinny down version of ignition. Let's talk about the core capabilities of the system a little bit.
Yeah, like I said, if you have any experience with ignition, right, it's the same, right? You're going to get, that universal connectivity, over 300 drivers. And I actually had to double check that to make sure I wasn't, that number wasn't being made up. But over 300 drivers that exist that allow, ignition edge to talk to other devices. If you use the ignition product in the past, you can always pair that. If it doesn't exist there, you can go through and use, a Kepware or a high byte, and it'll go through and talk to it. And both of those have slimmed down versions that can run in a Dockerized container as well. All the processing is able to be done right in ignition. I'm going to kind of steal the right side of the screen as it's facing me, right? So when we're talking local processes, it's got built-in Python scripting, event-based architecture. You can make the decisions right at the edge in ignition edge. The nice thing too, we talked about, what happens when you get disconnected from the main gateway or your central location. It's got a built-in SQLite database that enables what they call store and forward. You can get about 10 million records in there, which, depending on the complexity and speed you're collecting, is about a week worth of data. But it can sit there, process, save all, a week's worth of data without ever being connected to to a central gateway. Bob alluded to, again, the visualization control. We've used it multiple times, not only as an edge processor, but as an HMI for machine control, but also for sort of maintaining and visualizing what's going on with devices that are connected to that edge. And yeah, I kind of alluded to it before. You don't need to use gateway because this is basically ignition edge minus a couple of components. You can do all that processing, and you can use transmission to just push that data out to an MQTT broker. So, you might not want to use a gateway. You've got this ignition edge running in a containerized solution or in an appliance, and it's pushing everything out to MQTT. So you can use a other platforms to ingest the data. Obviously, we're big fans of Ignition. We do say, we really like using it, but the truth is everybody uses is at a different point in their digital transformation journey. So you might not want to let go of that visualization platform and that analytics platform that you're using, but you can still use Edge to pump the data in there, and then have your older systems or a different system go ahead and consume that.
Okay. And I think that fits in well with what we have in the next slide, where we look at Ignition being part of a whole system. And Bob, I don't know if you want to kick this one off or if you want Frank to handle it, but let's talk about how it fits within that overall picture.
Go ahead, Frank.
Right. I mean, so when we're talking Ignition Edge, we're talking sort of assuming it's going to be working with the Ignition gateway, right? And so this architecture, it does follow like a hub and spoke, with gateway sort of sitting at the center. When you do use Ignition gateways, these Edge nodes, they automatically synchronize to the gateway, and you can use that gateway to push out updates, deployment packages, just sort of do that central maintenance that we alluded to as one of the barriers that can all be done from a gateway that are connected. In a more complicated architectures, gateways can be connected to other gateways. You can specialize. One's doing processing, one's doing visualization. But you got to remember, at the edge, when you're going through that whole ecosystem, they're all talking to each other. That means the different levels, depending on access granted, can use the resources of the other. I'm a huge fan of this. Again, as I alluded to, there's containerized versions of this, which means you don't have to buy an appliance. If you've got a Wago PLC that supports it, you can go ahead and deploy Ignition Edge on it. If you got a Phoenix Contact PLC, you can go through and deploy Ignition Edge right on the hardware, and it's designed to go through and do that. Some of these PLCs are actually, they're what they're calling soft PLCs, 4-core processors, one dedicated to PLC work, allowing the other 3 to use these Edge services. We recently were, how can I word this? We submitted a proposal to one of the big 3. They're going through in their test facilities. They're going through and having machines. They don't have the visualization to the data these test machines are building. And when I mean test machines, they're testing it at their site for deployment at their powertrain facility, and then assembly some of these machines. So they don't have the entire suite of IT tools that they currently have there. These machines are being run off of a German IPC or soft PLC, which means the hardware is in there that hold these the Docker engine. So what we're proposing is throw Edge on here. We'll spin up a gateway to do visualization and whatnot. All the processing is being done at the edge. We're going to feed the gateway, which will not live in production. However, because we're using Edge, we're also going through and instantiating their custom CDM or common data model, and we're pushing that out to a broker, so that when it does land on the floor, they have an Edge device that is doing that translation for them into their CDM model right on the floor, and they don't have to worry about doing that part of the integration when it actually gets delivered to where it's supposed to go. And again, just showing the power of Edge and how it works and how it can be flexed within its own ecosystem, but also outside of it.
Excellent. Do you have anything to add to that?
I know I talked.
No, and that was a really good example, Frank.
It was a fantastic example.
I know I talk a lot, guys.
A little bit longer than we thought it would be, but it was a really good one. That was a great example with the big 3 automaker. Maybe what you could do is you could walk us through how some of these ROI numbers are calculated. Earlier on, I talked about the fact that one of the barriers for companies adopting these technologies has been that they don't necessarily know how to create that ROI specifically for doing an edge implementation. If you could walk us through some of the highlights of that, that would be great.
Sure. So I'll keep using that example. So we have a project, we're going to connect one machine, we're going through and playing it out. We're investing some time and money. Let's call it 30K. Just a rough number to go through and run through the situations. What are we collecting? How do we go through and instantiate that CDM? What does the visualization look like? And that's for one edge implementation for one machine. Well, when that work is done, and if you do it correctly, that cost is not for one machine. That's the cost for getting 2, 3, 4, 5, 6 machines. So when you start going through and aggregating, bringing that edge architecture, you're diluting that initial capital cost across all of it. And the savings, like the easiest way is the savings for integration to add on new equipment, new sensors. When you go through and you have to think through the implementation, but the amount of savings that you do when you get to 10 of these edge implementations, you're bringing down the cost from, that first one was 30, the second one was 0, so you can split that cost. So it's costing me 15 each. You start bringing down that cost, and you get to that point where it just starts paying for itself. You're not worried about developers coming and doing the work. To go ahead and stage an ignition edge implementation is, for all intents and purposes, dropping in the projects, and you tie in the signals that are coming in from the PLC. All the other work is taken care of. The publishing to the broker, the visualizations, because we're talking, in this case, we're using Ignition Gateway and Ignition Edge. The initial architecture, I'm not looking to see machine one, torque gun one value. When you start using some of those tools like UNS and CDM, so I'm just looking at, give me everything that's an attribute. Give me everything that's a set point. Give me everything that's metadata. And all those visualizations are tagged not to the individual signals, but to those UNS groups. As an example, again, this goes through the front end. There's always going to be more work to make sure you can stage yourself with success. And just a little plug for UNS. If you go through and do that, there's nothing stopping you from adding, another data type or data group in there, because all you have to do is update your core project and then push it down. And then everything on your gateway network, so all your edges, get the same update. They talk the same way. And again, you're sending that same information up.
Okay. I'll throw some comments in on this one. I've been, building ROI frameworks for a long time, and it's really about what are the additional capabilities that you're providing with what you're putting in. How are you fundamentally going to change the business and what the business can do tomorrow versus what you can do today? And then figuring out what that's actually worth. So, I think, Bob, you've mentioned in the past, what is the impact on the actual KPIs? And some of the KPIs that you might impact, there's a very obvious cost benefit, financial or dollarization associated with those. So if you're reducing scrap, it's very obvious how to translate that into dollars. If you're improving OEE, that might be something that's a little bit more complex, given the different circumstances and so forth. But if you're looking for a high-level ROI, I think there's a framework that we could share with that. If you're looking for a detailed ROI, that's something that we as a team also have experience helping companies put together. So with that, I think that the next topic is just getting started with Ignition. And I'll run through this one real quick. It's probably the easiest system out there to get started with, actually. There's a free trial and installer. You can download it and try it. It runs 2 hours, then you just have to restart it and so forth. But you can do your development and build your apps and so forth, and try it basically for free. There's online training and certification. There's tons of courses out there for all different skill levels and so forth. And there's a certification process if you want to go through that as well. And there's a very vibrant community out there, and integrated program, which Sandalwood is part of. And then there are partners like Sandalwood and so forth that can help you with this. And I'll put in a plug to Sandalwood that they are the best integrator that I've ever worked with, and that's why they're one of my key strategic partners. And do you guys have anything to add on getting started here?
No, you can get with the trial installer, you can have a gateway up and running, edge gateway up and running in 15 minutes. So it's one of the easiest systems to get installed and started on.
Again, I'll use that show how quickly it was to do. We use Docker, and we just made a compose file where you had a gateway. We have 5 edge devices. I mean, obviously it's inside a Docker network, but we were up and running with a SQL backend, and it was maybe 15 minutes. It actually took longer to write the YAML file for the Docker than it was to get everything talking. And that includes generating a simulator so we can just get some data pumping through there. So it's super easy to use, super easy to learn. And the community is engaged. If you are starting out on Ignition, look at the community, be a part of it. It's fantastic.
Excellent. So with that, let's wrap up for today. If you want to reach out, there's various contact information on the screen, including the QR code that you can scan there and get right to things. Once again, thank you, Frank. Thank you, Bob, for joining me, and look forward to the next time that we get together.
It's always a pleasure.
Thanks,
Tim.
Tim.
All right. Thank you.